Hello friends, welcome to my channel. Today I will tell you about the most important topics and chapters for ISRO examination 2017. In priority basis I will tell you which chapters you have to read, and in fluid mechanics we will get around total ISRO questions are 80 questions. Out of 80 questions in fluid mechanics we will get around 10 to 18 questions, and in thermodynamics 7 to 15 questions, heat transfer 5 to 10 questions, engineering mechanics 5 to 15 questions, mathematics 5 to 9 questions, then production 10 to 20 questions. Production includes metal cutting and metrology both. Strength of material will get around 7 to 12 questions. Then vibration will get 5 to 7 questions. In machine design 5 questions. Around 5 questions, not exactly. Then refrigeration 0 to 3 question, industrial 0 to 3 question, theory of machine 2 to 5 questions. Total 80 questions in 90 minutes we have to solve. So most important is fluid mechanics, then production, then thermodynamics, then engineering mechanics, strength of material, heat transfer. Heat transfer questions are easy but time taking. Without calculator little bit difficult, otherwise same formulas are repeating. Strength of material, sometimes tricky questions they are asking, sometimes easy questions. Mathematics also questions are repeating. And then subject wise I will give you the analysis, which chapter you have to give more importance and which chapter you have to give less importance. Fluid mechanics I will cover both fluid machines and fluid mechanics. In fluid mechanics and fluid machines we will get around 10 to 18 questions. Here important things are, first is bulk modulus. It's represented by K. It's minus dp by dv by v. Here they will ask problem. Using this formula we have to give the answer. And one important thing is here, for ideal fluid K is infinity. Then specific gravity S, density of fluid by density of ideal fluid. Then dynamic viscosity mu, its unit is important, poise. Sometimes they will ask you dimensional analysis. For this dynamic viscosity dimension they will ask you, so this is important. Then kinematic viscosity, it's mu by rho, unit is Stokes. Here also they will ask you dimension, both are important. Sometimes they may ask problem also, dynamic viscosity and kinematic viscosity, both relation you have to use to answer that type of questions. Then Newton's law of viscosity, this is also important. For theory and problem, both they can ask. Tau equal to mu du by dy. Theory question also they may ask. D theta by d. Du by dy is velocity gradient. D theta by dt is a rate of change of angular deformation. Or rate of shear strain, both are important. Here graph also important. Shear stress versus velocity gradient graph. This graph is very important with examples. See the Newtonian fluid. Then here n is less than 1, pseudoplastic. Examples are very important. And this n value, n is greater than 1, dilatant. Then here Bingham plastic, n equal to 1, Bingham plastic. Then less than 1, greater than 1. Greater than 1 is rheopatic, less than 1 is thixotropic. Here n is less than 1 for thixotropic fluids and n is greater than for rheopatic fluids, and for Bingham plastic n equal to 1. Then examples are very important. Water is Newtonian fluid. For all examinations, these examples are very important. Milk, blood and plant, it's example of pseudoplastic fluid. Butter, example of dilatant fluid. Printer ink, example of thixotropic fluid. Then gypsum solution in water and bentonite, it's rheopatic fluid. These two graphs are also important. Shear stress versus time. Here for rheopatic fluid, shear stress increases with time, and for thixotropic, shear stress decreases with time, and strain rate is constant. And here viscosity versus velocity gradient. Newtonian fluid, it's constant, and for dilatant fluid, viscosity increases with velocity gradient, and for pseudoplastic, viscosity decreases with increase in velocity gradient. All three graphs are important for ISRO examination and IAS examination. And for other examination like SSC JEE, first graph is important. Viscosity of liquid is due to cohesion and molecular momentum transfer, and for gases, viscosity of gas is due to molecular collision. And viscosity of sometime in problem they won't give you this value, so you have to remember this value. Viscosity of water at 20 degrees Celsius, 1 centipoise. This value you have to remember. Or in poise, In problem they will not give you this value, so you have to remember the standard value. Then compressibility beta, it's inverse of bulk modulus. So beta equal to 1 by k, 1 by minus dp by dv by v. In problem solving you have to use this formula. Two, three times they asked this question, bulk modulus and compressibility. Problem you have to solve. Then surface tension. In surface tension, water sigma value is, this value you have to remember. Sometimes they may not give this value. Surface tension of water is 0.073 Newton per meter at 20 degrees Celsius. And three things are important here. Pressure inside liquid drop, its value is P equal to 4 sigma by D. Then pressure inside soap bubble or bubble, P equal to 8 sigma by D. And pressure inside liquid jet, P equal to 2 sigma by D. All three formulas are useful in solving questions. They will ask in problem. And one more thing is important, theory. Surface tension is due to cohesion only. This is also important. Here capillary action also important. Then hydrostatic law. Capillary action formula is H equal to 4 sigma cos theta by rho GD. They will ask height of the liquid column, rise in that tube or fall in that tube. You have to solve that question and answer. Rho G term and specific vector. And capillary action is due to cohesion and adhesion. This is also important. Then hydrostatic law, dp by del z equal to minus rho g for upward direction of z, and p equal to, from here p equal to rho g z or rho g h. Standard value for air density is 1.2 kg per meter cube. Sometimes they may not give in the question, so you have to remember this density of air and density of water. For density of air it's 1.2 kg per meter cube, and for water it's 10 to the power 3 kg per meter cube. Thank you friends. This is the end of chapter 1. Like this other chapters also I will give in later videos. Thank you.